Hi, I have another video on probability, but in this video I'm going to show you how to use theoretical and experimental probabilities to make predictions. Now what I did is I did a little experiment of tossing 3 coins and taking notes on all of those different results. Now I didn't just do it, but I had 3 other people help me. I just want you to keep in mind I am subject 1. And those of you close to me might know who subject 2, subject 3, and subject 4 are. But I'm number 1, so looking forward, I will be that person. So when I did my experiment, 3 heads only happened 1 time. 2 heads 8 times, 1 head 9 times, 0 heads 2 times, and I had a grand total of 20 times where I flipped these 3 coins. Now I'm going to use those results as I move forward, because I want to look at what's the experimental probability for tossing all heads. And I'm going to look at it for me. Now, so I can see both, I'm going to split my page here. There we go. So I look over here and I go, well, probability of all heads, that only happened 1 time for me. So I have 1 out of 20, which would be my probability. I could turn that into a decimal. It might be nice. Oh, not 0.5, sorry. Let's try that again. How about 0.05? So 1/20th or 0.05. If I look at everyone, so everyone, all heads, now everybody had that happen 6 times. So when we put all of us together, we're going to end up with 6 over. Now the grand total for all of us is 80. So 80, that fraction simplified comes out to be 3/40ths, which as a decimal turns out to be 0.075. So when we put all of our results together, the probability was better for getting all 3 heads. Now, if we go to no heads, for me, I had 0 heads or all tails happen 2 times. So my probability would have been 2/20ths or 1/10. Turn that into a decimal, 0.1. If we put everybody together, notice that happened 10 times. So 10 out of 80, which would be 1/8. If you turn that into a decimal, that comes out to be 0.125. So again, everybody together was better than me alone. Now on my next page, it's going to look at the experimental and theoretical. So it wants to know, how does our experimental, which is on the left side, compare to the theoretical, which I'll put right here, for tossing all heads or tossing no heads. So I put the sample space here of what could have happened, those different scenarios. So in my first one where I want all heads, I got to look in here and go, well, here's a scenario where I get all heads, and it's the only one. So 1 out of, well, there are 8 different outcomes possible, so 1/8, which as a decimal comes out to be 0.125. Now if I go to no heads, I'd have to do the same thing. How many outcomes are no heads? That would be all tails here, and that's it. So 1 out of 8, which again is a decimal, is 0.125. So it says, how does your experimental probability compare to your theoretical? Well, I look at, if we compared it to mine, let's go to the 1/8 here, and my 1/20th. Well, my probability was much lower in the experimental than the theoretical. So I wasn't as lucky. If you look at all of us together, we still weren't as lucky as probably what we should have been theoretically. If you go to the no heads, again, I was a little bit below when it comes to my luck compared to no heads over here. But when you look at all of us together, our experimental probability ended up being exactly equal to our theoretical probability for getting no heads. Now that brings me into my next slide, which I'm going to go back to single pane. Right here, it says, why do you think the experimental and theoretical probabilities were different? Which in some of our cases in mine, they were different, but some they were not. I have my little explanation here that I typed up before this. I said they're probably different because theoretical is what we mathematically expect to happen, while our experimentals are based off of what actually happened in our experiments. So they don't always happen to come out to be the exact same thing. Now, Question 4 I put here, what do you do to get more accurate results for the experimental probability? Well, that, we just run the experiment longer, make it go more, flip the coins more often. So I wrote down, you could continue this experiment, flip more coins, which I look at, if you just took my results, they weren't as good as if you compared them to all of our results together. So that's where extending the experiment. I did it and 3 other people did it. That's like extending the experiment. The other thing, it says the more outcomes, or in this case, the more times we flip the coin that you have, the closer you should get to the theoretical probability. So if we can run an experiment hundreds and thousands of times, we should get really close to that theoretical probability. Now, here's where this lesson is what I wanted to talk about. It's how can we use it to predict it. So it says, using the theoretical probability, how many times would you expect to get all heads if you toss 3 coins 600 times? Well, then I have to go back and think, well, what is the probability of getting all heads when I toss 3 coins? And we just did that. So the probability of all heads is 1/8. Now think back to what probability is. Probability is our ratio of our successful outcomes, or the ones that we want to get, that would be here in the numerator, over the grand total number of outcomes, which is here in our denominator. So successful over total is the way I like to think of it. Now we have, in this problem, we have that we're going to flip the coins 600 times. That's the total number of times we ran the experiment. So the total has to go in our denominator, like the 8 did. Now the question becomes, is what goes in the numerator? Well, that would be the number of times we get 3 heads. We don't know that, but now we have these 2 ratios that are going to be equal, and we can now solve a proportion, something we've done many, many times. In this situation, I would look at cross multiplying. So I'm going to end up with 8x equal to 600. And then I just go ahead and I solve this problem. So I'm going to divide both sides by 8. And I just found out that x is going to equal 75. So if I were to flip these 3 coins 600 times, I could expect that I will get all 3 heads on my coins 75 times. Now, what happens if we use my experimental probability? So now we got to go back to my data. Now, if you remember, when I tossed it, my probability of getting 3 heads was 1/20. Remember, I wasn't quite as lucky as theory tells me I should have been. So I get 1/20. Well, same thing's going to apply. We have these 600 times we flip it. That's our total. Over, well, how many times could I expect if my luck stayed the same? And again, we have our 2 ratios. We solve our proportion. I'm going to cross multiply. So now I get 20x equal to 600. Divide both sides by 20. And for me, x comes out to be 30 times. So like I said, I was not as lucky as theory tells me I should have been, because if I'd have done this 600 times, it looks like I would have probably ended up with only 30 of those cases where it was all 3 heads. Now, let's go here using theoretical probability. How many times would you expect to get 2 heads if you toss 3 coins 600 times? Now, this is where you'd have to go back to that sample space to figure out, well, what is the theoretical probability of getting 2 heads? And if you go back and look at your notes on sample space, where that sample space was at, you'll notice that the theoretical probability of getting 2 heads was 3 out of 8, or 3/8. And then this isn't going to change. We still flipped it 600 times. So my 600 is going to go in the denominator. We don't know how many times that we'll get it, but we have our 2 ratios, and we can now solve our proportion. So again, I'm going to cross multiply. 8x here. Here I get 1,800. If I divide both sides by 8 on this one, I'm running a little short on room. I'm going to bring my answer over here. So I'll end up with x on the left side equal to 225 times. But what happens if I use my data from when I did the flipping? So if you go back to my data that I put on that first screen, I flipped 2 heads 8 times. So my probability with my experimental probability was 8 out of 20. 8 times I got 2 heads, 20 times is what I did total. Again, we have the 600 times we're going to do this experiment. So that's my total. How many times would I expect to get 2 heads? So come here, solve my proportion. This time, you know what? I looked at this. I don't like doing it that way. To me, it's going to take a little longer. I noticed this. If I take that 20 and multiply it by 30, I'll get right to 600. So then that means I'm going to have to multiply this 8 times 30 to figure out what x is. So that's going to put me at a value of x equal to 240 times. Now here's what that tells me. I look up here and go, well, the way I was going, I was apparently more lucky to get 2 heads than what theory tells me that I should have been. So when it came to 3 heads, I wasn't as lucky, but with 2 heads, I guess I was luckier. And that's going to conclude my lesson on using our theoretical and experimental probabilities to make predictions.